Hello everyone, and welcome to today's presentation, Top-Grade GraphQL, bringing the worlds of JSON and RDF together. We'll start today's webinar with an introduction to our speaker. Holger Knoblauch is the lead developer at Top Quadrant and also the editor of the W3C Shackle standard. Holger will introduce GraphQL and explain how it can be used to query RDF-based data. He will provide a practical walkthrough of the new features of the upcoming top-grade release 6.0 that uses Shackle to define what data gets exposed to GraphQL clients, which fields can be queried, and what kind of filters can be applied based on the underlying schemas. Holger will also show how the JSON delivered by the GraphQL service can be used to drive custom applications and the recently redesigned query builder of Top-Grade Edge. With that said, let's review a few logistical items. Please feel free to ask questions as we go along by using your GoToWebinar controls. To pose questions, please look on the right-hand side control panel, and you should see a drop-down box for questions. If you click on the box, you should be able to post your question at any time during today's presentation, and we will address as many of those as time allows at the conclusion of the webinar. We'll also be recording today's webinar, and we'll be following up with each of you with a link to the recorded version as well as to the slides. With that, I'll hand it over to Holger to get us started. Holger?
Yes, thank you. Hello, everyone. I'm going to get right started with a couple of slides, and then I'll try to be fairly interactive with this presentation, so I'll also give live demos. All right, so the big picture that I'm trying to talk about today is really the transition between RDF graphs and JSON trees. So if you think about, you have a database on maybe on your server or in your application, and graph databases are becoming increasingly popular, and obviously graphs are a very suitable mechanism for representing all kinds of knowledge. However, on client applications, you typically just need a small snapshot of this overall graph. So you need to somehow extract a structure that a client can process, and client applications typically like to work with JSON data. It's very easy to process and easy to read format. And that's what really this presentation is all about, how to get from a graph structure into a tree structure that gives the client or any other application that is wanting to process the information enough data for whatever task it has to do. So, and in this presentation, this is a brief overview. I'm going to introduce what GraphQL is, and then I'm going to show what technologies we are employing to bring GraphQL and RDF technologies together. Then I showcase the types of GraphQL queries that can be executed using the top-grade platform. And I'll briefly at the end touch on the topic of how to use GraphQL for running updates called Annotations, and also talk a little bit about how to take any JSON data and convert it to RDF using the same approach. Then we'll have questions at the very end. So please feel free to type them in as you wish. All right, so what is GraphQL? And I'll turn over to a little bit of a demo. GraphQL has been introduced by engineers from Facebook a few years ago, and it has become a very, very popular standard for querying all kinds of data. It's called GraphQL not because it's really optimized for graphs or that it is limited to graph structures, but primarily because the data that Facebook has is graph shaped. typical the network of friends and so on that they have. That was one of the drivers of this project to begin with. You can find all kinds of information about GraphQL. There are books about it, etc., etc. So for those who have never seen it, I'll just show you how typically GraphQL queries look like. The window here that I'm showing is a little application called GraphQL, which is an open source project that is the de facto playground that many people are using to play with GraphQL queries. And well, GraphQL queries are very easy to write. Basically, you just put curly braces and then you define what fields you would like to get. So in this case, I'm querying. This is a database about Star Wars. It's the standard demo that people typically give for GraphQL. So I'm following the same. So this is a very small GraphQL query that is just delivering the name of a person with a certain ID. And just to make it a tiny bit more interesting, I'm also getting the height of that person. So I'm entering the query here, and then I'm pressing this button. Basically, you're not seeing that I'm pressing the button because I'm doing it with the keyboard. But basically, you enter the query here, and this is the result here on the right-hand side. This is the JSON coming back. And you already see that one of the ideas of GraphQL is that basically you define the type of objects that you want to get back. You define the structure of the objects. You type them in field by field, and you get basically the same structure that you have requested as JSON. And there are various data types, like you have integer and other numeric values. You have floating point values. You have strings. You can have arrays, like if I'm searching for what movies does that person appear in, this would be an array result. Or you can walk into neighboring objects, adjacent objects, like the friends of that person. And to do that, you just ask for the property name, and then you open up a new block, and this will be turned into another object. So I can get the name of the friends. And I can also learn other things about the friends of the person where I started with. So it's very flexible, and it's more flexible typically than comparable query languages on the web. So it's often compared with REST-style applications. So this is more flexible because it gives much more control to the client application in what fields are needed to answer the needs of the application. So, and this is making it increasingly popular among web developers, but also being a query language, it's not limited to web development. It's also suitable for all kinds of other data analytic tasks or whatever else you want to do with your data. So this is what I've shown here is just a canned demo. It's a standard demo running against a generic GraphQL service. What I'm showing next is that basically the same thing can also be executed within TopRate. And here I'm running against data that I have currently open in TopRate. So this is now TopRate Composer, just for a second here. I have, in preparation, I have converted this example data into RDF form. And then in the new TopRate version, which by the way is for those listening live, this is the new TopRate version is available as a beta today. You can download it if you like. So basically you can open any file, and then you can just go to this menu item here and open it in a web browser using the same interface that I'm showing. And once you do that, so let me switch back to the browser, you can start putting your query in, just like I did before. So let's say I want to ask for humans. And for every human, I want to get the name and the height. So here we go. This time it's querying the RDF data that is currently open in TopRate. So it's a live query now. Well, and there are all kinds of filters that are supported. Once you are in RDF mode, you can ask all kinds of interesting questions like, well, find me any human that is at least 1.6 units high. And I'll talk about what type of queries are supported in a later stage of this demo. And so how does that work? You've already seen me typing in things, and as I start typing, the system is actually suggesting the fields that are available. And how does it do that? So one of the key principles of GraphQL is that GraphQL is driven by schemas. So every GraphQL endpoint defines a schema, which is then defining the fields that are available and their data type, etc. And actually you can see which fields are available in this documentation panel here on the right-hand side for any GraphQL endpoint. And there you can see the type of queries that you can run, what fields are available. Like here, you know that you can ask for the URI of any object, you can ask for a label, and then the properties that are defined in the RDF data model. So, and this one here is this Voyager application that I'm showing right now is an open source tool for viewing GraphQL schemas. And what I have open here is a visualization of the schema of the standard Star Wars demo. So you see concepts like humans and droids, and there's also what's called the root query object, which is basically the top level thing that you can start with, which is also kind of like an object with fields for entering your data structure, basically. And then you have starships, etc. So, and these schemas are typically represented in GraphQL's own schema definition language. And I'll just show you how that looks like so you can get an idea. So I've opened a typical GraphQL schema file here. And let's, for example, look at the definition of a type human, which I've queried here. The syntax is fairly easy to read, hopefully, but you get the idea. So you start defining types, which represent objects in the result. And then you just write down from top to bottom, you write down the fields that are available. And for every field, you basically have a name and then the data type and a little bit of other information. Like name is a string field and the exclamation mark means it's mandatory. So you can have a very small number of semantic constraints, if you like, as well. And you can define array types like this. And every field may also take parameters. Like in this case, the field height takes a parameter called unit, which is of type length unit. And these parameters can be used to, for example, filter values or to sort and reorder values. All right. So with this, let's get back to the PowerPoints for a few slides. So what has been our motivation to do that? So obviously, many applications want JSON output for their data. GraphQL is very easy to use. You can basically give it to anyone and they'll learn it within a few minutes, really. With a simple user interface, it's very difficult to do things wrong. So now, of course, what are the differences? And there are differences between the RDF world and what can go out in GraphQL. So we've tried to build a bridge between those two worlds. And in particular, we are using Shackle, which is a W3C standard, to build this bridge, basically to define how the RDF query, how the GraphQL queries are mapped into RDF world and which data is queried. So Shackle plays a similar role to the GraphQL schema language, only that it's for RDF. And it's a W3C standard since last year. And it's similar to, it's kind of similar to OWL and RDF schema, but it has richer semantics. You can express more with it, if you like, in terms of constraints. And it is not based on classes. So one of the main differences between Shackle and other RDF ontology languages is that you have a more general concept called a shape. And shapes are similar to classes, but they are more general in the sense that you can use them to describe data independent of triples in the data model. So you don't need a type triple, for example, to use a shape. And this means you can also have multiple shapes for the same objects in your database. Okay, so you can basically define multiple views on the same data, and that's an interesting feature of Shackle that is useful for GraphQL as well, because you can define basically the types of queries that you want your users to ask, and you're not limited to whatever classes you already have in your ontology, but you can define your own shapes, new shapes, just for the purpose of querying. And another key feature of Shackle is that you can define property paths, not just simple properties, but also you can, define a property that is in fact walking a couple of relationships away from where you start, and that's quite convenient sometimes. All right, so in the next few slides, I'm just briefly touching on the relationship between GraphQL and the RDF worlds and Shackle in particular. And I'm going to start with, well, at the most basic level in GraphQL and in JSON, there's really just a handful of data types that are available: Booleans, floating points, integers, strings. And, well, obviously there is a straightforward mapping from Booleans to RDF Booleans using the XSD data types, and also for floating points, RDF has something very similar, and it also has double and floats, and well, all of them can be mapped into a GraphQL float. Integer, likewise, there are many integer types in RDF. In GraphQL, it's all a single one, and string and any other data type like dates and date times that are not available in GraphQL can be mapped into GraphQL string objects or string values. So that's a very simple, straightforward mapping, and it goes in both directions. So everything that I'm showing here on the next few slides can be read in both directions. So you can either start with your GraphQL schema or with your Shackle data structure, and the system is able to convert between those two worlds seamlessly. So here is an example type definition in GraphQL, and at the bottom you see the corresponding Shackle data structure in turtle notation. And what you can hopefully see straightforward is that every type can be mapped into a shape in your Shackle, and every field in the GraphQL structure can be mapped into what's in Shackle called a property shape. And then things like arrays would be fields that would be property shapes that have I was pointing at the wrong thing here, by the way. So arrays would be property shapes that have no limit, no maximum number, while simple fields like name would have a max count constraint attached to them. So, and you can go back and forth from both sides. So if you already have a structure in Shackle or maybe in OWL and you've converted it to Shackle, you can start there and the system will generate the GraphQL schema for you, and then you are ready to ask your queries. GraphQL also has a very simple notion of inheritance, but it's a really much simpler version of inheritance than typically available in RDF data languages. It's really just one level using interfaces and implementations. And this also has corresponding equivalences in Shackle. You can either define classes and then use subclass of, or you can use the sh::node property to define basically that human is a specialization of character, or it's a subclass or an implementation of character, if you like. So there are a couple of other features in GraphQL, but it's a fairly simple language, so there are not many, but I'll just show briefly that they also have equivalent constructs in Shackle. So GraphQL has union types, for example. It means you can either use human or a starship in this case. And the corresponding Shackle structure would be an sh::or. And there are enumerations like colors, yellow, red, pink. Enumerations have a corresponding syntax in Shackle using the sh::in property. And that's about it. That is built into GraphQL, really. These are the main features of the schema language of GraphQL. If you want to go the other direction, if you already have a Shackle structure where you have used some Shackle-specific features, like in this case, I've defined a min-inclusive constraint, saying that an adult is someone who has the age of at least 18. So you can use this also in GraphQL if you like, or in GraphQL syntax with the extensions that we have defined. And this is where so-called directives come into play. So GraphQL has its own extension mechanism that anyone can use to put additional information into a field or a type definition. In this case here, the syntax is, well, you just write it after the field that you have defined, and then you say, using this symbol here, you put your keyword, and then you can put parameters there. In this case, we have defined a library of GraphQL extensions for expressing Shackle core constraints, like min-inclusive, min count, max count, and all these other typically used features. And that allows you to basically go seamlessly. You can start your definitions in GraphQL if you like. You can still use Shackle-specific features, and they will be turned into Shackle RDF on the fly. So another difference between GraphQL and the RDF world is that RDF has a notion of namespaces and of URIs. And that is very powerful, obviously, for those familiar with RDF. It's a mechanism to link data from different databases together and to reuse concepts or classes defined in other files and in other places. So to represent them in GraphQL, we have again used a small extension because GraphQL only has simple names, doesn't have this concept. So we have introduced a directive called prefixes, where you can define the namespaces that are used, and then you can define the default prefix. In this case, this here is used as the default namespace for any identifier in your GraphQL schema. So human, for example, would be turned into HTTP Star Wars, etc., /human, or yeah. And this again allows you to start with GraphQL if you're more familiar with that. You just put a couple of annotations into your GraphQL schema, and the system can then figure out what RDF resources it needs to produce or it maps to. And this, as the last feature here, I think I'm going to show is last but one. This is this mechanism for defining namespaces and URIs also makes it possible to link multiple GraphQL schemas together, which is a strength of semantic technology in general, which is not available in GraphQL out of the box. So in this case, for example, you can define a type actor, which is referencing a concept called movies from another namespace. And using those annotations, the system TopRate is able to make sense and to link data from multiple namespaces together. So the last feature here in this comparison, Shackle provides a reasonably popular feature for defining form layouts, if you like. So you can define shapes and you can define fields for them or properties for them, but you can also then put some annotations on them to say, well, how should this be laid out in an application? How should data that matches this shape be presented? Like, for example, you want to have, for a person, you want to see the names, given name, family name from top to bottom, and then you want to have another section on your form for the address. So you can define this in Shackle using a couple of annotation properties like sh group, sh name, and order. All that is present, but it's not really present in GraphQL. So we had to define, again, a couple of annotations that allow you to annotate your existing GraphQL schemas to capture the same information. And we have introduced an annotation called display, where you can exactly represent the same information. All right, so with all that said, why did I give you all this background? Well, it's basically the motivation for our design, because we believe that GraphQL and Shackle, or GraphQL Schema and Shackle, fit together really well. There are lots of similarities. However, the main difference, obviously, looking at the size of the user community and the ease of use, is that GraphQL is, for whatever reason, much more popular than RDF-based technologies. We are really talking about millions of users learning GraphQL every day and using it in web applications. And there is a lot of open source and commercial tool support for GraphQL as well. While RDF has the strength that it has a much more flexible data model. It's not just about trees, it's about whatever you want to store in your knowledge graphs. And it has the concept of URIs, and it introduces subclasses. So it has some valuable additions to the GraphQL world that GraphQL doesn't really have out of the box. And that includes things like rich semantic constraints that Shackle has. So, and the approach that we have taken in TopRate to get you started, you can either start with an existing with an existing Shackle file with your schema definitions, or you can also just start with a GraphQL schema in the native GraphQL format. Or you can start with an OWL or RDF schema file that you have. You can convert any OWL or RDF schema file to Shackle using TopRate. And from any of those starting points, the system is generating a GraphQL schema that is then that you can then query. And it's not just taking whatever is defined here, but it's then providing additional features that I'm going to show next that can be used to, for example, filter values or to order values and many other things. And all this happens automatically from whatever starting point you have. So with this, let me go back to the demo for a second. I have shown you that you can open, so I have not really shown that, so let me show that. So I had shown you this GraphQL file here in a text editor. I can, now in Top-Rate Composer in the new version, I can also just open it directly as an RDF file. And when I do that, the system is automatically turning the GraphQL type definitions into corresponding shapes. So, and then there you have the RDF shapes and the property definitions, and it's all available now on the fly. So here it has defined a property shape for the appears in field, and it points at an episode, and it's the first property, so it has order 0. So it's doing all that automatically, and based on that, you have the flexibility to define your schema in GraphQL if you prefer to do that in a text editor of your choice, and then just open it on the fly, and then you can move to querying it. Top-Rate web products also have an ontology editing feature. So this is now Top-Rate Edge, our enterprise data governance system. It also comes with its own schema and Shackle or ontology editor. And here I'm showing the same data structure as before, so that you can see which types are defined, which shapes are defined, or which classes are defined. So all kind of the same thing. And then you can define properties and constraints on those properties using this editor. All right, so now let's get back to the features that we have available for querying data in GraphQL. So I go back just to reactivate my Star Wars instances file, so that it's the active one that I can now query from the web interface here. So I've already shown you can ask for all instances of a certain class. In this case, I'm asking for all the humans, and for every human, I'm asking for the name and height. So one of the first features we have added is to have ordering, because typically RDF data is unordered. It's basically a set of triples. So we have added an attribute called order by, which allows you to specify what field do you want to order the values by. And now they come back in a sorted fashion here. So starting with the lowest value, or you can also turn this around, this in descending order, starting with the highest value and then going down. So, and again, as I'm typing in those features here, you can use autocomplete. It suggests what values you have available here to put in here. So after ordering, there is a feature for matching values. So you can say, if you just want humans with a certain value, so I want to have, for example, the human with the ID of 1000, you can use this syntax here. You basically put the field name and then the value that you want to match. And then the result will be limited to only those instances that are that have this value. And you can use this for any other field as well. So for some more flexible search capabilities, if you want to filter by for example, strings or by text, we have added a built-in field called query text, where you pass in a regular expression. Like if you want to find anything that is starting with L, that would be the syntax here. You say query text and then starts with L, and you only get the instances back that meet this criteria. And it's, when you use query text, it's basically looking for all the properties that are available for the given instance in your data model. So this is for basically simple string searches. For more flexible filtering, we have added a comprehensive syntax for matching values in that have certain property values or that match certain constraints. And the syntax for that starts with a field called, or a parameter called where. And you can use that, for example, to say where the height of a human has min inclusive of, say, 1.6. And you have various other filter fields available here. They resemble what is available in Shackle as well. So you can, for example, ask for regular expressions. You can ask has value. You can ask for minimum, maximum number of values. And you can combine all of them. And you have similar expressivity to what is typically available in comparable query languages here. For example, I could ask for well, find me anyone who has at least 4 friends. You do that by saying friends min count 4. And again, you only get those back. And more complex queries like this one here, which I'll not type in, I'll just paste that in for a second. So this complex query here is asking for all humans where there is a starship that has a minimum length of 30 units. So in this case, it's returning this instance here. And then I'm requesting the starships of that instance. In this case, he has 2 starships, and one of them is indeed longer than 30, this one here. So you basically can put fairly expressive filter conditions here. If you then only want to get basically the starships back that have a minimum length, you can still do that, but you have to put this down here in the field where you actually fetch the values of your instances. Like in this case, if I want to find only the starships where the min length is say 30, I can do it like this. So and this is now returning all the humans that have at least one starship that is 30 units long, and then for every human, give me only those starships that also have this condition. All right. So, and if that expressivity is not enough, you can also fall back to Sparkle, which is a popular RDF query language, and you can run queries like this one here. Using the filter keyword, you can put arbitrary Sparkle filters into your query. In this case, I'm asking for everyone who has a minimum height of 1.6. And you can put any other expression here. And the system is using variables to allow you to access field values of the current object. Like in this case, height already has a value when you run the query, so it's fairly readable and maintainable syntax. So another feature here, you can ask for counts. So if I want to find out, well, how many people are in this knowledge base at all, I can ask humans underscore count. It returns me 3 entries in this case. And here you can also limit this. For example, give me the count of humans that have a certain height. Height min inclusive 1.6. How many do we have now? It's only 2. So basically, that's a mechanism for aggregations, and there's another type of aggregation supported for building large string concatenations. I'm not showing that, and in the future we'll also have more features there, I guess, for building sums and other typically needed features. So finally, and then that's one of the last features that I'm showing here, we support transformations as well, based on small Sparkle expressions. You can transform values on the fly. In this case here, I'm asking for every human, I'm asking for the name, but I want to transform the name into uppercase. So you can do this using this operation here. uCase is a built-in Sparkle operator. And you can use the same mechanism to do, for example, transform numeric values from meters to feet. That's what I've done here. So it basically allows you to transform data on the fly. And you can also use our query interface to compute new values that are not even in the database at all. And we have defined a couple of derive fields called derive int, derive string, derive float, etc. You can use them to compute things from the data, even if they're not defined as a field. In this case here, I'm making up a field called name length, which is not in the database, and I'm calculating this as the string length of the name of every human. And it's returned here as a number. Okay, so finally, for application developers, another important feature in GraphQL is the ability to run reflection queries, and reflection queries allow you to query metadata about what is available. And this is also how this whole user interface is driven. It first queries the server for, well, what types do you have and what are the fields of every type. And this can be used, for example, to build input forms or to use to drive queries, etc., etc. So just to mention that this is also available. Okay, so this was a short demo of a number of the built-in query capabilities of our GraphQL service. What I'm showing next is how you can use GraphQL under the hood without even knowing that GraphQL exists. So in the new version of Top-Rate Edge, we have redesigned our search interface, made it more user-friendly and a bit more powerful. And this looks like this. So you basically can type in your query up here. You can filter by a certain type. So for example, in this case, I have a data asset collection open about database tables and database columns. And I want to search only for database columns. And it shows the results down here. And you can use this interface now to return more columns, for example. If I want to say, if I want to also see the total number of values, well, you can do it with a simple click. You then get more columns in your result table. And this is under the hood using GraphQL, and you can actually see the GraphQL query that is executed while you are running your searches. In this case here, it's well, it's just producing a simple query that is fetching the URI and the label of every database column, and then it's fetching the number of values here using this field. And if I'm adding another column, this would also be added. And if I'm adding a filter, like for example, where the total number of values is at least 100, and I run the query like this, it's also using GraphQL under the hood, and it's generating the same queries in the syntax that I've shown before, using min-inclusive and other features. So you can either use this interface here in Edge for querying data, or you can switch to advanced view, in which case you can directly enter your GraphQL query if you prefer to do that. So it gives you a lot of flexibility, a lot of power. If you're reasonably familiar with GraphQL, you can run these queries now within the Edge editing environment. All right, so wrapping this up, because we are reaching the end of the presentation. Let me go back to the last few slides. We were at, we've seen all that, so let's go back to here. From here, okay. So last two topics here that I just very briefly cover. GraphQL can not only be used to query data, but it can also be used to perform updates on your data. And the syntax for that is fairly similar. You are also using fields, and you can pass in parameters to your fields. And we have, from your starting point, whatever starting point you have, if you have a GraphQL schema or if you have a Shackle data model, the system is automatically generating some additional update fields that can be used to perform updates. And in particular, there is, for every shape, every type in your data model, we are creating a create operation where you pass in a JSON object, and the system will then create the corresponding triples. Or you can update an existing instance, and again, you're passing in the JSON object, and then you have the fields and the values. So, and what this basically allows you to do is you can use this GraphQL support for client applications that first fetch instances from your database, from your RDF database, and then you can, on the client, manipulate the JSON objects into another JSON object, or modify an existing JSON object based on user input, for example, and then send it back in exactly the same format with just some values swapped out. So you can round trip quite easily. And also, this is where one of the strengths of Shackle comes into play, because we have Shackle constraints on the database. You can use this to validate the data before it gets written. So you can say, well, only make sure that the data type is correct, make sure that minimum and maximum values are used correctly. So you can use this GraphQL interface to test your data before it gets submitted. So you can do kinds of dry runs. You can send your data, and the system will return with a validation report and will notify you about which fields are invalid. And then if you're happy with the result, you can say commit, okay, and execute on the change. And then it's just returning you how many triples have been added and deleted, a little bit of other metadata. So all this comes automatically from whatever Shackle structure you have defined. So, and very briefly also, in the new top rate, there is a feature that may be useful for some of you. If you interact with existing JSON data structures, for example, delivered from a web service, the GraphQL mapping to shapes can be used to turn any of those instances into RDF triples, which might be interesting if you, for example, have multiple requests for different data. The mechanism that we have defined allows you to merge them all together, to basically turn all those trees back into RDF graphs on the server. All right, so that was basically what I wanted to show. If you are interested in this further, you can now download Top Rate Composer 6.0. It's now in beta release, and you can briefly show that for those getting started. So you can open Edge from Top Rate Composer from your personal edition, or you can also get an online evaluation account if you prefer to use it online. You can apply for that. Instructions were on the slides, and you can find that online as well. But once you're in there, you can either run your GraphQL queries from here to play with the system, or you can directly go to a tutorial which we have added, and this explains all the features that are available, and it's interactive, so you can play with the queries. You can run them in the tutorial if you prefer, and hopefully get started with this very quickly. Yeah, so there are lots of examples in this tutorial, and you can activate and execute them on your current data, whatever data you already have. With this, this last pointer here, we have a web page that is linked from here. This is providing all the details of the GraphQL mapping. Includes all the technical background that you may or may not want. So please look around, and yeah, otherwise, hope you find this useful. It's the first version that includes these capabilities, and we are improving as we go along. Let us know what other features you would like to see in future versions. And this finishes my presentation, and well, we can turn to questions.
Great, thank you, Holger. We've got quite a few questions, so we're just going to jump right in and start. We'll start with this first question. What is the relationship between GraphQL and Sparkle?
Yeah, so GraphQL is similar to Sparkle in the sense that you can use it to produce small snippets of, or small excerpts of your database. GraphQL is a much simpler language in terms of its syntax, while Sparkle is much more optimized and much more powerful because it's obviously made for RDF data. So if you're happy to use Sparkle, you can continue to do that. But what GraphQL offers in addition to that is the ability to produce JSON tree structures, while Sparkle is limited to tabular data, just really rows and columns. While with GraphQL, you can basically produce arbitrarily nested structures. However, if you are not happy with what you can express with GraphQL out of the box, well, I've shown that you have these fallback mechanisms, so you can embed small Sparkle snippets into your GraphQL query if you want to. Okay.
Okay. Great. We'll go to the next question. Does your top-rated platform server support this GraphQL by default now?
Yeah, so you can currently GraphQL is available for any of the data asset collection types that are available in top-rate Edge. So for glossaries, taxonomies, and all the other features, it's not available for ontologies right now because ontologies don't really fit into the schema. They are kind of meta schemas, and they change too frequently. So we have, because those schemas, basically those GraphQL schemas are generated on the fly, and there's little cost of generating those GraphQL schemas. We are offering them basically for all instance data, not for schema level data right now. But if you have your own Shackle data models or your own OWL ontologies or whatever, you can query them now out of the box, and we have a servlet for that, and we have Sparkle motion modules and all the typical stuff that you may want to use GraphQL with.
Okay, great, thank you, Holger. Let's see, let's go to this question here. Is there a way to express equivalence like OWL equivalent property?
Okay.
Right. Is there a way to express equivalence like OWL equivalent property?
Yeah. So that's a good question. So you can, of course, combine GraphQL with OWL inferencing, and that's maybe one answer to this. So you can run an inference engine, and then obviously the system would produce additional triples, which you can then query. So if you have two similar properties like given name and first name, and you declare them as equivalent, well, then they would both be fields in your shape, and you can query them, and the system would find the same values for both of them.
Okay. Thank you, Holger. I think we have time for one or two more questions. Let's go with this one. Can Edge also edit Shackle annotations?
Yes. So the Shackle, yeah. So that's more of a general Edge question, obviously, but yes. So the Edge ontology editor provides features for defining form layouts. So you can edit things like property groups and the ordering of properties. And we also have a simple graphical viewer for your form layouts. And yeah, I mean, any other Shackle feature is available through the web interface. The syntax for some of them is, of course, a bit complex because Shackle is very powerful and very complex. So for things like intersection and unions, etc., you need to fall back to turtle notations in some cases, but we are working on this. Yeah, but any other type of annotation and Shackle feature is editable through Edge.
Okay. Great, thank you. And I think we have one more question that we can get to. How about this one? Are you doing anything or have plans to surface JSON LD via your GraphQL functionality?
That would be possible. We have not done that yet. So the main thing that would be missing is that in the response, we would not just return the data, but we would also have to return what's called the JSON LD context, which is then allowing JSON LD applications to parse the JSON fields back into corresponding RDF properties and other RDF values. That's possible. We have not done this yet, hopefully in a future version.
Great. Well, thank you, Holger, for today's wonderful presentation. And we will go ahead and end today's webinar. And I'll remind everyone that there are several questions that we were not able to get to, but we will be providing answers to those questions in the form of an email response to all attendees. We will also be providing a link to this recorded presentation as well as to the slides. So just be on the lookout for that next week. We hope you will find today's information valuable, and thank you everyone for your attention. Have a great day.